Okay, so welcome to the fourth lecture, fourth week of aspect software development. Of course, that's why I always say what course this lecture belongs to. So this is it seems that according to the title, it seems that we will relax a bit from aspect J, but this is not quite so. Nevertheless, we will talk about analysis and design in aspect-oriented software development, and we will draw or I will be showing you some pictures, and we will talk about pictures mostly, but then we will look at how this is reflected in code, and I hope you get accustomed with aspect J, more or less. I hope there are no substantial problems. So you went through some examples, and I will add. You will see, and you can see actually these examples are already there in the corresponding the folder corresponding to this lecture, lecture 4, on Google Drive. Not too much code, so just two examples. Okay, so we all know that software development requires planning and establishing the initial idea and organizing people and everything, and to other people over the ideas and such things. And when we do this, we usually draw pictures. So this is not related just to software, just to any activity. And our field is not also is not special in that we developed we are developing standardized notations, standardized or like common notations, conventions on how to draw those pictures in order for the pictures to be understandable, readily understandable to other developers, other participants in this process. So for aspect-oriented software development, it might be that something else is necessary, something different than we have traditionally seen in UML. But there might be some things in UML also that are related to this. So we'll see this, but before that, let's look at some analytical things and start like with not too detailed expression of our ideas by developing some kind of an analytical model. I have here an example which is expressed in requirements. Not all requirements are here, and it's about developing some security system. So imagine that we are developing a security system, and we have among the requirements, we have these 3 requirements. One is that each alarm bears its ID and indication whether it is connected to a special sensor. The other one is when the security system is being shut down, all its sensors are being turned off. So we are getting a glimpse that there are some alarms and there are some sensors, and that probably alarms are kind of run if something is detected by the sensors, and but we are not going to treat all these things. We are focusing on the shutdown operation, turning off the system. This seems as a kind of an easy thing to do, straightforward. But then we have this requirement suddenly that alarms placed in buildings and connected to special sensors are excluded from being turned off during the shutdown of the whole security system. So we might even imagine that like for some applications, these security systems need to be highly customized or customizable to different conditions. We might have them like for this building it would be a bit different and more complicated than for a small house. And you might even imagine like you have then not just a building, but you have an area around the building, and some if you have a flat then it's just that those sensors and alarms are inside, and no point of thinking of anything else. But if you have a house, if a yard and everything, or such a building with an area around that belongs to it, then you might have some sensors connected, some sensors there also installed. It means outside of the building. So we might think of this requirement for cheaper versions of the system. This might be kind of something additional, although it's not explicitly stated here. So if we would like, I'm not satisfied with the configuration. So if we think of these requirements and you know, maybe about these, I can speak even louder. If you think of these requirements, then if you would like to express them, and if you would have many more requirements like this, you might get an idea of expressing or putting them in a picture in a form of some kind of what they call mind map. Do you know about mind maps? I tend to perceive this concept as a kind of freestyle graph, so you put whatever you need there. So if we would go this way, then certain what elements do you see should be there in such a graph? Looking at the requirements, what elements, what kinds of elements, what would you put in that graph? I think that one kind of the elements is obvious.
So sensors? Sensors?
Sensors? Yes, but what is a sensor?
Probably some mechanism, probably some agent which will detect something.
Yes, but related to the specification, like what kind of
node? I don't know.
Yes, it would be a node, but it's a kind of an object that or a thing that the specification refers to. Some kind of, not an object in some entity. It refers to some notion.
Observer.
You see, no. I'm talking about with respect to the graph that we will draw. So we will have one kind of node that is just in front of your eyes, but you were reluctant to name it, are requirements. These will be nodes. as well. This is one kind of node. So requirements certainly are a thing that you need to capture in your picture. And you want to relate these requirements somehow. One is related to the other, to connect them. Not all requirements are related to each other. It might be really an abstract thing, like just connecting the bubbles, like some kind of unspecified association. And but this you will know. Okay, if I'm implementing this requirement, then I have to look into this and into that requirement and so on. That's how that picture could help you. But apart from this, you might think also of the entities, objects, notions that are mentioned in requirements. So alarms are here and the alarms are elsewhere. This is just about sensors, it seems so.
Security system probably.
Alarm there, security, yes?
Security system can be counted as an object, or it will be...
As well, yes. And even some processes can be the notions that you want to capture or whatever. So some notions that you encounter, characteristic notions, also might be a kind of a node in your graph. So kind of roughly speaking, there will be two kinds. There are two kinds. If you just think of this of the specification, not just this specification, of a specification. These two kinds of nodes, if you do not want to go too much into details, are what we are going to represent in our picture. And exactly like this, some other people have been thinking and developed this kind of notation. So, just two kinds of nodes. These are requirements. This one is it's the same, but this one is like I've put the whole text into the node. Sometimes you can do this, sometimes you can't do that. But these nodes are no different, are the same. And the other kind of nodes are like this, like what is it? Some kind of rhomboid or something like that. And just to distinguish them graphically. And some of them, it's not complete, but maybe you could imagine some other. If you would carefully study the specification, you could imagine adding some other nodes here. Some other notions, some other topics or themes that occur there. So these nodes are called themes, and these are requirements. So these themes that we talk about, that the specification talks about, are explicitly stated here, and actually there's one condition that was introduced with this notation, that no two requirements can be related to each other directly, because we want to see how are they related. So if you just draw a line from one requirement to the other one, how do you know how they are related? You could do this. There could be a notation like this. But this is a kind of a methodological twist, that we are drawing pictures like this, but with one limitation. So the notation forces us to express directly over what theme requirements are related. This is not object-oriented. This is not aspect-oriented. It's kind of just like exploring the domain. So we want to be free from the implementation space, implementation domain, or realization domain, and then look for the appropriate mechanisms to implement what we need to implement. So as we will go deeper into design, we will be then turning to our realization domain mechanisms. So for now it's free. So you can see that if you would study the specification, that like this is a kind of a more like a process entity. This is a kind of more like a data entity. But nevertheless, there's always some behavior, and there will be some behavior related to alarms and certainly to shutting down the system. And looking at this picture, you can see that there are these themes are shared among the requirements, and the question might be whether we can limit or constrain the responsibility for the requirements for these themes. Which requirement is responsible for which theme, or actually vice versa. Which theme covers covers which requirement, and we can switch from this view to something like this. The idea is to constrain the responsibility. So we see that this requirement R8, or I need to better stand here to be able to switch back and forth. So we see that this requirement R8, which intentionally I actually put its text there in order to have it in front of our eyes to see that what is it about. So this is a kind of a shared, very much shared requirement between the themes. All other requirements here, you can see that, well, some theme has two requirements connected to it, but these requirements are not shared between themes. So we switch perspectives. So the themes become those active nodes in our mind that will be representing or will be enabling elements of our software system. So these will be our elements, not the requirements. And we want to determine the responsibility for implementing the requirements with respect or from the perspective of these themes. So we see here that these requirements are this theme is responsible fully for these two requirements. No other theme is connected to these requirements. But this requirement is a shared requirement between several themes. So we put the responsibility, we transfer the responsibility to one theme, and say that this theme then is responsible for enforcing this requirement onto other themes. I could have selected maybe some other theme to be responsible, but when we look at these themes, exclude alarms connected to special sensors, shut down the system and alarms, and when we read this text, that alarms placed in buildings and connected to special sensors are excluded from being turned off during the shutdown of the whole security system, it really seems that that this team is kind of more mostly in the position to take responsibility for the whole process that is stated here. Because we need to include alarms connected to special sensors. This is the key thing. And for this, it will take the responsibility and somehow manipulate other themes. We don't know how yet. Somehow manipulate other themes to achieve this. And this is how we restructure the picture, like this. So we say that R8 is fully on, exclude alarms connected to special sensors, we disconnect it. And we use these arrows to indicate that this theme enforces this requirement, which is not shown exactly that it enforces R8, but enforces some things into shut down the system and alarms. I think I need not say that this looks like an aspect affecting those two themes. And we see this already in the application domain. So we are not yet, we do not say how is this to be realized. We are not bothering with these kind of details, but we identify in the application domain, we identify an application specific thing. This is not kind of one of those generally applicable aspects like security, persistence, and such things. There was a fight over this in the past. Some people claimed, in particular one person, claimed at the aspect-oriented software development conference that there are just those generally applicable or technical aspects, and there are just few of them, maybe 4, I don't know. The application domains are aspect-free. There could be no concept of aspect of an aspect in an application domain, and then some other people, and he claimed to have proven this mathematically, somehow, logically. There is a paper on this. And I put a reference, I think, to this lecture. If not, maybe some later, I'll transfer it to this lecture if it's elsewhere. And then who is curious to take a look at this. And some other people then responded to this. That this is not so, this is different. And there are indeed application domain aspects we can identify. This camera or
yeah.
Flying away. Okay, so now we have a kind of when we get a glimpse of what we need to do with or what we need to do within our software project, the time is to add the details. So to say how things are really to be organized. And when we think of aspect-oriented design, what would you identify? What do we need to express there? When we have this object-oriented design, usually we use class diagrams, although we could use some other things in UML that are kind of do not force us to directly think in classes and objects. But when we put objects and or actually classes, we see some relationships between them, like associations, if we are not certain what's happening, but mostly aggregation, inheritance, some what's called dependency. Dependencies means that something affects, like calls something or constructs an object out of that or whatever. That's again a constructor call. And roughly that's it. Because in aspect-oriented programming, you have aspects that affect some elements, maybe even some other aspects in your program. And then, how do they do that? How do they affect other elements? There are two ways, actually. You can say that from aspect J, two ways. We talked very much and emphasized those elements called advice. So they change behavior. They add some, they can prevent some method from executing, or can execute that method repeatedly, conditionally, whatever. And there's the other side to this. There's a possibility to add structural elements, to add some attributes, and even operations. There are with this respect, there are structural elements. So you're adding new operations to some classes. You don't do this in object-oriented software, in object-oriented software development. So one view that you need to construct is how these elements are being added. So aspects affecting other elements or whatever. So what's happening and what is being added. It's a kind of the basic view, like that you work with. We introduced aspects because we need to decouple these things and do not want things mixed up. But on the other hand, you need to compose these things in order to make them work. So if you introduce some new elements into your classes, then there will be a class in the end composed out of what was in it before, plus those new elements. And if you need to affect the behavior that was there, then there will be this old behavior and plus this new behavior around it. If you use an around piece of advice, or before it, or after it, or whatever, instead of it. And this is a kind of a mechanism to compose things, and then you get the final picture where everything is composed. And you can see how it looks like as if you have not been using aspects. I guess I need not emphasize that this composed view might be useful for analyzing some things, but this is not the view where we start. We start with the aspects affecting what's happening, and we want to see them decoupled from the other things. So your notation should be kind of capable of expressing all these things, but we work essentially with this view that decouples aspects from the rest. And in this theme approach, which is like what we saw so far, was is called theme, and it's called theme doc, like documentation, like the analysis level thing, those graphs that I've shown to you. And this notation has the design, its design part called theme UML, because it's based on UML. So the authors did not want to go far from what is a convention or commonly used in our area. So the notation is based on UML, and you really, indeed, you can see here a very simple UML diagram. Recognize this is just one class, and this one class is put inside of a package, but the package has a stereotype. I talk a lot about packages in many courses these days. So this is a very simple package, nothing very special, but that stereotype. This one looks a bit different, but I think that at the time that this notation was created, it was not really possible to do this in UML according to UML specification. But I think that now it is possible to include some other kinds of diagrams in packages like this. You're never sure if a highly inconsistent UML specification, actually when it's that inconsistent you can do almost everything. But I think that the idea, there is an idea like this there stated, I'm not really sure, but if it's not there, we are very close to this. So you need to package the things not just in your model, and the tools are using this. In Enterprise Architect, you use packages to partition your model, not just to partition for the sake of clarity of the model, not to introduce packages in terms of what packages will be in your software system. And two perspectives are being mixed, because when you draw a package, you would like to see its diagram, so you put that diagram inside that package, and there you are. And you might, why couldn't you put some other diagrams related to that package and have everything together? So you have not only the structure, which is displayed up there, and this is a little bit complicated structure, but you have this sequence diagram. You might have other behavior diagrams included there as well. And these sequence diagrams, I did not use this found message. Maybe I should have used it. I think that in the original theme notation, there is no this symbol of this field in circle, to indicate a found message. Found message means that message came from somewhere we don't know, from where we do not care. This is used when you want to specify generally what an operation does, to provide a graphical elaboration of a method, to say so. It is not important who called it. So this is your method, and this is its body in object-oriented terms. I'm not fully following the theme notation in some things. Maybe if we would carefully study the things that I'll be showing to you, maybe it's not exactly by the book, but it's not that important, because there is no tool that actually you will be using and that will be capable of showing everything that you need with this notation. What is important is the idea. So for now, I think with this I'm pretty close, but it will be worse in the next picture and the following pictures. So for now, it's just like plain UML, actually. apart from that we are packaging everything together like this in one package. Maybe there was no concept of a room there in the requirements, so I'm adding a bit of elements there to make things more complicated, because you'll need to show more complicated things in aspect related to designing aspects. So the thing is that the shutdown is on the alarms that are turned off in the rooms that are in the buildings. So buildings consist of rooms, because you don't have it's just the rooms of whatever kind, maybe even corridors or whatever. So that, it means nothing if you say just an alarm is placed in a building. It's a too big thing, so you must specify where it is in terms of rooms. And the shutdown goes like this. To get things work, what we do, we compose these two themes. So we have alarms, and we have this concept of shutting down the system. When we get back to this, you can see that, okay, well, I have alarm here. Why do I have to compose this with this one? Oops. There are some other elements there. So it's not just that this class can be turned off, or an object of this class can be turned off, but there are other things. So there's also this turn off concept here repeated. So when we'll be composing this, we will have to decide what has precedence, or maybe the versions will be the same, or whatever. So the composition might be easy and straightforward, but usually takes some effort to specify how elements, and if they are not named the same, how related elements overlap. And these themes are actually partial views of the system, so we see that we do not express everything here. We are missing things even here. They will be introduced by other themes that elaborate these concepts. And then we compose everything into a whole. Is this object-oriented? Not anymore. Is this aspect-oriented? Yes or no? No? You know. Not yet? I think that it is. Recall that symmetric aspect-oriented composition, where we compose the elements like two classes and combine their elements of equal quality or equal level. Not that an aspect affects a class, but that two classes are combined, just like that alarm class is combined in two versions that are present in two things. Maybe this turn-off operation here should precede this one. So we'll be having like a small piece of advice there, like some more asymmetrical way of composing things. So this is kind of symmetrical, and then asymmetrical can be like inside of it. But these two entities, like themes, and those classes inside are seem to be of equal level, equal quality. We do not say that this one is an aspect of this one, and this one affects this one, and so on. Like in an asymmetrical aspect-oriented programming. Aspect J is very limited with this because you can just introduce elements and you're introducing them by aspects, and this seems like just another way of asymmetrical composition because you don't have really equal level elements there that are being composed. But you can pretend that you can do this by having by having just stamp classes, like just empty classes, and introducing everything by aspects there. So you'll be eventually working with only one, mostly with only one kind of elements. An aspect in aspect J unfortunately cannot establish a new class. You can add elements to existing classes, but you cannot produce a new class, completely new class that was not there before. So this is a symmetrical aspect-oriented composition. Yes, I have this picture like this, but actually it's not very readable with this projector, so we can see here better what's happening when we see everything what's inside there. But in the end, what I wanted to draw your attention to is this expression here. So this special arrow is no longer UML like this. It looks like a bidirectional dependency, and there's an expression that states what's being constructed. So it says this because a new theme is being constructed like this, generated, and that's why I said that we might need now a new view where this security system theme will be displayed. We don't see it as an element element like this because it is an element that's being generated, constructed, and it is constructed by matching the elements by name. So the simplest form. So we do not care about. We assume that equally named elements, if they are implemented like both of them, then they are actually just like the same. So only one version is used. So you can specify these rules like in text here or somewhere aside. But what's happening with our exclude alarms connected to special sensor theme? So we see here this theme represented in the theme approach, and it looks quite different. There is this parameterization box there, so it is a kind of a parameterized or template package. There are no template packages yet in UML, but there are template classes. Let me show you just this figure. We'll get back to this. This one is from UML, the UML specification. And you can even do this in enterprise architecture, for example. So you have here a generic array class that is capable of taking whatever elements, so elements of type T, and it can be an array of any length, so K. And the default value for this is 10. This is a template class. Just like you have templates in C++, you have generics in Java, in C#, something along these lines. Of course, UML enforces its own way of generics, and it does not provide kind of, unfortunately, just like with classes. You are forced to, like when you draw UML classes, you are forced to obey the rules that are imposed on you by UML, and then translate that design into your programming language. It's not that class diagrams are more general in UML than the classes are in programming languages. There are specifics to how they are understood in UML. Some things might be not completely defined in UML, so you're kind of free to interpret this as you wish. But in the end, there are heavy limitations to this. Even you you cannot have anonymous classes. A concept that you know from Java in UML. You cannot represent them in UML. You can represent them somehow, use some stereotype, some special classes, and say that okay, this is my anonymous class, and I want to represent it like this. But there is no such concept inside of UML, for example, and access modifiers work in a certain way, but in programming languages they might work in another way. And you are forced to comply to UML specification. You can change it in some way, but you cannot change all the things. And the same with this. So how this works in UML is that there is this bind expression. This is kind of without this bind expression, this relationship is something you recognize. The realization relationship. Sometimes it's called implementation, but officially it's realization. So this element realizes this one. Usually you see this in interfaces, this realization. That a class implements an interface, but here it is used with this bind stereotype, and it changes its meanings substantially. That it means that this element actually realizes, actually repeats what's here, but binds the expressions that are presented as its parameters to specific classes, specific types, or specific values. And then you get this address list of length 3. Not very usable, but that's not mine example. Or not very useful. So the concept of binding, but this was not present in UML at the time when the theme UML notation was constructed. Let's get back to this. So this composition. Oh, this theme. First, let's look at this theme. So here we have again just plain, like seemingly plain UML class like this, and we have this yet another sequence diagram. But the things are a bit special here because this class and its operations are named. Actually, its operations, but implicitly also this class are named as parameters, stated as parameters to this package. So parameters, as you saw even now in contemporary UML, come from the outside. That's normal. Happens all the time in all programming languages. So they come from the outside world, and then you get a complete version that can be executed or used. Otherwise it's not complete. So it's intended to get some things from the outside world in order to function. work. How is this, like if you would have this just put inside and okay, these are the operations, no, not a very useful thing because it does nothing. So you need to express this behavior, and this behavior is expressed again as a sequence diagram. And this sequence diagram looks like a normal sequence diagram, and we might say that nothing special is there, but there is one thing. This do operation is a convention to represent the actual method body. So it's just a naming convention introduced in theme UML. This might have been something else to emphasize, like some stereotype or something else. Maybe that would be an appropriate thing to do in UML, but they did this. So it's just underscore do underscore. So probably then you cannot use the names like this in order not to like confuse the reader of your model. But otherwise, the idea is there. Like an operation is being called. What operation? Well, this operation here. Or what class or operation class? We will get this. So some operation that is being called is then being executed like this. So its body is being executed here, but it's not executed at all times. It's a part of an optional fragment, and there is a condition to its execution. What kind of condition? Well, I don't know. It's implemented in this method. I will get it from the outside. Yeah, so, and as you might expect, this is to be composed with some other theme, and you must then say that what is being composed, like this is this bind expression. It's again the same kind of edge or arrow, bidirectional edge like this, dashed one, a dashed one, and this bind expression states the values of the parameters. And here is where I'm not really sure about this UML, theme UML notation. So there is a sequence of these parameters, and in very complex situations you might have several sequences. So this is why you have these, they are called angle brackets. Like these like less than and bigger than what's called symbol. So these are like additional brackets. So not just these square brackets, but these angle brackets are here because we might have different sequences of these parameters. Maybe if there's a repeated binding or something like that. We are not going that deep into theme UML. And if you would be kind of using this notation, you would probably need to reconstruct it somehow and restate some things and a bit change some things in order to work with your favorite modeling tool, to make it work with your favorite modeling tool. So that's not that important, but the concept is that you are transferring these parameters. So this is a cross-cutting theme, or colloquially an aspect theme. This cross-cutting theme cross-cuts what's there by introducing this whole mechanism that we stated here. And to what is this being introduced is stated by these parameters. So there is this turn off and in the order of occurrence. So turn off and has special sensor. So here the initial what we capture is this turn off method in the alarms in the alarm class, and we actually check whether it has sensors by this method operation, and then decide whether to execute the turn off or not. So eventually we implemented this requirement that we had of conditionally turning off the sensors, but this is not the whole thing. So the composed picture, like this, but it's even smaller now. You can depict these. Well, I did not depict these alarms. I think it will be kind of too much for the slide to see what's happening. But here at least we have this bind expression, and we can compare things. So I don't have to switch back and forth, but I think this is not very readable from where you sit, unfortunately. Anyway, this is how this asymmetrical composition is being done. So this is the basic thing. So now, when we look at this, we could have expressed this in terms what we know, like this. Maybe this kind of something that you haven't used yet, or not that much. It's similar as this, but on the other side. So this is a target class. So this is a class that actually where this call is present in. So this is this operation class, and this is this turn off operation. We cannot specify this in terms fully of this. We can use this operation class as an interface, but we cannot really have this generic name of the operation there. But roughly, this is what we would have in aspect J. I think I even have this example like this in Eclipse. So if we go, this is this more elaborated one, but this one I wanted to show you first. So this is the alarm class, and there's this turn on, turn off constructor, has special sensor. This is what we need. Has special sensor and turn off are most important for us currently, and this is the implementation of the aspect theme. It is not fully corresponding to that aspect theme, but at least is kind of closer to it by since I've used this not concrete but an abstract aspect. An abstract aspect, if you haven't seen it so far or used it so far, is an aspect that cannot be, just like a class, cannot be instantiated. An abstract class does nothing. also the same holds for an abstract aspect. Why do we create such things that do nothing? Well, we put some things there, organized, modularized things there, and we can reuse these things and devise concrete things out of these, devise some things out of this, and fill in the missing details, make the things concrete, and then they become highly useful. So this is it. This is with this abstract aspect as well. So what we should have here is this point cut operations that eventually will operate upon this operation class, which we don't know what it is. So as we don't know what it is, but we cannot just expect the compiler to assume that there will be something like this. So we need to state this. So that's why I placed this interface, but I placed it inside of this aspect because it's not. This is something that is not very useful to the outside world. So I keep it inside of this scope, so it's not valid outside. Actually, I think you can somehow access it, but I'm not really sure. But my intention is to keep it like to show exactly to the programmer, to others, to readers of this code that this was meant to be a local thing. So this local thing is then what we rely on here. And this local thing has this operation and condition. This comes directly from that aspect theme that we've seen a few minutes ago. And we cannot specify the point cut. And we can have an abstract point cut in aspect J, but we cannot elaborate it to a certain extent and then fill in the gaps. This cannot be done. So I cannot fully follow the design by this. But what I can do is at least I can implement behavior. And this is how abstract aspects are typically used in aspect J. So they do not specify exactly the places that you affect, but they specify the behavior. And then that behavior is introduced at those places that you introduce by implementing this abstract point cut. Whatever is abstract needs to be implemented in the devised element. And the devised element is here. So the most important thing is here. So this point cut. It's being implemented like this. And this condition I need to implement as well, because it's kind of, you need to state what is it, and it is calling this has special sensor method, which is actually a part of the alarm class. And how do we do this? We need to introduce this method into the alarm class like this, because it actually needs to be connected to this whole thing in order to be able to call this. And in order to be able to do this, we need to enforce this implements relationship between alarm and operation class. This is something that you don't really see in the design, but in the implementation you need to do this in order to get things work. We could try something like this, as shown here below. But we cannot capture such calls. There are no calls to operation, there are just calls to turn off. So we would have then this point cut like this, very like directly like what we had in the design. So we will not mix these two perspectives. One is this generic perspective, and the one of general perspective, and the other one is specific perspective. Now, there is no way to avoid, in the kind of implementation of aspect J, there is no way to avoid this, and we need to refer explicitly to the turn off operation. So how does this work? There should be some example in this alarm. I have a security system. Security system constructs several alarms, and they are turned on, and then by this aspect we actually do something with them, follow what's happening. So what does it do is that here we have this turning on, so this is reported, and then we have this this is reported here. Then we have turning off, and this alarm turn off is being captured if an alarm is connected to a special sensor. To special sensor, there is only one alarm connected to a special sensor, because when you look at the alarm class, its constructor says here Boolean special sensor, so true or false. So when we get back to this security system, we see this one is connected to a special sensor, but otherwise not. So this is kind of just to turn on and off, or follow the alarms being connected to special sensors overall. I'll get back to this later. So this is what we do for now. And we might be happy, okay, things work somehow, don't spoil them. But we are not happy fully because we need to turn off only the alarms that are placed in buildings. And that's what this requirement table says. Alarms placed in buildings and connected to special sensors are excluded from being turned off during the shutdown of the whole security system. So there's one more level there. So it's not just that overall. Plus, I introduced an additional complication to this because I introduced rooms. So they're not just buildings, they're also rooms. And the whole situation then looks like this. How did I manage like this? Again, forgot how to enlarge this normally. Let me see. jump out of this and maybe make this bigger like this. Have one more way of making it bigger by using magnifier. I don't know why I can do this without my mouse. I actually found a way to do this, but I forgot how to do this. So let's use self-replication. No, this might be too big, but anyway, okay. So what do we have here is this a new version of the exclude alarms connected to special sensors theme, and here we have this operation class again, but our sequence diagram is far more complex. So I generalize over the idea of having buildings and rooms, and do not use these notions explicitly, but I'm saying that there are main objects and there are parts. And these main objects are actually our buildings, and parts are rooms, and there could be some other parts then as well. But that's the other thing. But let's see how this works. You capture this shutdown operation again on that main object. Then you can do something with its body. So it's do shutdown. What do you do there is that you just let it go. You execute this shutdown, and you follow it further. And then you follow this shutdown operation. You capture this shutdown operation. It's not the thing that you're following yet, and you let it go, and you capture this operation again, and you again have this optional combined fragment where you had it before. So you go all the way within this control flow and capture what you need. So it's actually graphically expressed point cut, and this is something, and of course the parameters that you have correspond to that. So you need to have all of them like this. Maybe I should have shown this main object class there in the design here graphically. I'm not sure whether I must do this or not. I'm not sure. But that's a detail. So this more complex point cut that we would have here would be like this. Like this. So this is the more complex point cut that we will have here. We actually go capture this call and then control flow of the building shutdown, and then the control flow of room shutdown. This is if we want to be precise, completely precise, but we usually want, we could use even this within code, but that's a detail. But what I wanted to show you further is this. Who knows how many, well, you can have a room, and the room within a room, maybe somebody will add this concept to the system. Who knows how that would be. So we are not interested in this part of the control flow. We are just following control flow in order to get here. and this is expressed by this arrow. This is not a part of theme UML, not within the theme UML. So this is being added. I think some other people also thought of this and added this notion or notational extension to the theme UML. It's a kind of an indirect call whatever levels are there, and our point cut becomes much simpler, like control flow, just one control flow, because we are actually following the control flow building shutdown, which is our main object, and then we capture just what we need, the external operations. And just see what I have here. This is the topic that we will treat in a minute, but let me just show you quickly, and you will play with this within the lab after the lecture. But let me just show you what's there. So this alarms building project is this more complex thing. So where you have a building, and the building has a list of rooms, and you have this room that actually can have several alarms, and so on. Everything is being reported that so you can know where you are. And here you have this conditionally skip operation aspect, and now you understand the concept of abstract aspects. So no wonder that we again have this abstract aspect. So here the thing is that we keep it as it was before, because the complexity is in the point cut, and the point cut is the new point cut is being created here. There are several versions to it though, so let me put them like this so you can see what's happening. So here you have this just the first attempt that is not really what we are going to do, because it is not limited to the rooms, and we get it better, like improve it by this. This is you can try this on your own. So with two control flows, what we had before, and we can look at this. This is our, let me put this control flow here below. So this is within code. You can try this one as well. And the final version, that is most general one, which does not is not affected by if we would add further levels of rooms to this. So the original theme UML did not take into account the possibility to have this control flow point cut completely, like in aspect J. So in one way, like aspect J is kind of above this, like goes one level above the ideas that are presented in theme UML. But as we saw, we can easily enhance this notation by adding this indirect call like this. So when using theme UML, I think it's good to use this additional thing. And this additional thing actually comes from one from another notation that we are not going to discuss in detail, but I will just in a few minutes show the basics of how could we graphically model pointers. The idea is to your point cut, actually, if you think of a point cut, is a kind of a query. You are querying your programming model, your program. Get me some things from there, from my program. Like you're querying a database in SQL. And there is a way to query graphical models as well, and you can query them like in textual by using textual expressions. But you can imagine querying them graphically, like this. So I would like all the classes that start with my, no matter what's there after that, with foo and foo, but not foo, but a variable starting with foo and bar and or whatever type and so on. So by using some kind of regular expressions, you can express what you need to capture, and then you get these elements.
This is a point cut?
This is not yet a point cut, but we are heading there.
Mm-hmm. Okay.
And why is it not a point cut? We don't know what we captured, really. So, but this is just to show that we could imagine using not operator like this. So not a class that starts with my and that contains no integer attributes. We could imagine even structural queries like this. So, but this is just a plain UML diagram. Nothing, those what they are called? Slip my mind. These characters, symbols like star and
cardinalities.
no cardinalities, but like the missing parts you indicate by those wildcard symbols. Wildcard symbols, no wildcard symbols, nothing. So we are capturing exactly this configuration, exactly this one. So this could be also a query. So a normal UML diagram can be also a query. But we could say something like this is where this symbol came to me, like from this notation. So an indirect inheritance. So maybe there are some other levels of inheritance, but in whatever, like, and I could use like a star here. So whatever class is derived from a graphical object.
What does it mean that indirect inheritance?
Like there could be
aspects.
No, there could be some other levels of inheritance like this.
Just what? How can it be represented in the code?
Let me show you this picture, like this, like special graphical object, and this could be circle there, something like this. And I don't want to show this, so I say whatever is there, I don't care. I capture this configuration. So if there is such a configuration, I'm identifying this configuration. So my query language captures this for me, because the model are constructed exactly So there are really like this is a strict notation, and everything is deterministic there. You can imagine a program that would take out such elements, and there have been some attempts to make this. It's a wonder that I don't know about any commercial modeling tools that implemented such a thing, and you are looking for such things constantly in your models. So it's crazy. You have all different kinds of different possibilities, but this one would be kind of a very interesting one for that. And you can do this even in behavioral diagrams. And actually, this is where it came to me. Like, why not use this from not that one? This one is exactly what we need. So this is a kind of like a behavioral configuration that we could capture. So whatever calls are there and so on. Probably when we do not name this here, we cannot capture it. But if we put, this is another thing. Let me show you this. If we put the things like this, that we state what we are interested in, and that's what Nikita asked about. Now it becomes a point cut, because we know what we are capturing now. So we declare somewhere this. So the notation says it should look like a bit like this. I'm mimicking this notation, not fully. That does not fully correspond to this. I'll go back a few slides and show you the exact notation. But this is what the symbol is. This question mark, and this is how we mark the things that we can actually capture. So security system shut down, and there is an operation that we capture, this call, and we capture this object, and then we can operate with them when we capture them. So in this is a simpler structural point cut, where we capture all the objects of a certain class. Like this. Maybe I should have used these square, not square, but angled brackets as well here. Yes, I used them. The operation is put inside of that, and there's this question mark. It's a kind of a convention. You can choose whatever convention you wish. And this is just my version of the diagram, but not important. What point cut would it be? Again, we can write this in aspect J, and that's how this notation works. This is another thing that we can use, and very complex. We can use. We can create very complex situations like this to capture this particular joint point here, this search operation. This is something that we can imagine to be combined with theme UML, but there's been some attempt to this, but no other work has been done with this. It could be interesting. The thing is that sometimes we really need to play graphically with our point cuts, and this could be useful if you have a model and you need to talk about your point cuts in terms of your model. Then this notation is very useful to express what you need. Otherwise, you would need to use like aspect J like this, and then follow what's happening in your model. So it's like a not meant to be used instead of programming, but in order to show things, to communicate things, to talk about things, to design things. And as point cuts, as you know, are the most complex thing in aspect-oriented programming. Then maybe you don't need anything else. You need your object-oriented things, and then you need those point cuts. So that's the idea. So it can be combined somehow with theme, but it really doesn't matter now. Like there's a paper on this, so you can skip this. Anyway, it's not like did not look that useful, but the place where you can combine it, where you can, as you can see at least from this picture, if I draw your attention here to this bind expression, is to make a more precise expression of your bind expressions. So let's leave this like this, and let's conclude this lecture by these few words. Aspects can be identified already in requirements. Aspect-oriented design needs to sufficiently expressively capture the structure and behavior and to define their composition, both asymmetric and symmetric, but independently of programming language mechanisms. This is what we saw in this theme doc and theme UML notation, and this what is it called? Suddenly forgot the name of this notation. These aspect-oriented queries. This is another way just to focus on pointers, not structural things as in theme, in a complex way as in theme UML and theme doc. You will be using these two approaches to express your design in your project, like in that separate, like that's a kind of separate what's it called, path in your project, or you actually take to just to implement some things to try aspect-J and to try these things and show them. So you will be using these two, not these queries that I've shown very much, or you might use them, but it's not that important. So it's not explicitly part of that. Okay, that's it about aspect-oriented modeling. We continue with use cases again. If I'm right. So let's see. Just for a moment. Where we are. So lectures and here. Aspect-oriented design patterns, and we continue with use cases. Okay, so these were JPDD. Sorry for about not mentioning. So those point cut designation, those queries are called joint point designation diagrams. So we are here, or we are done with aspects in analysis and design, theme and JPDD. Mostly theme, just a bit of JPDD, and we continue with aspects and use cases, and we will be getting back to, don't worry, we will be getting back, although it's not stated here, to the theme approach again. So you can think of it, and we can continue with your questions and clarities regarding the theme approach in the next lecture. Are there now any questions? Currently. Okay, I exhausted you. I'm sorry about this. I thought it would be a bit quicker or shorter, but anyway, we can like give you half an hour for a break. It's that's fine for you, with you? Okay. So half an hour. Thank you for your attention, and see you, not really me, but Jakub and Victor will continue working.